we're going to do a special application of what we learned last class. So, and we're going to see how it applies to particle problems in particular. We're going to be focusing on how can we use those integral functions that we used last time to deal with particle problems. What can they do for us there? And then also we'll be looking at comparing and contrasting the concepts of distance and displacement. For those of you guys in physics, you may already understand that difference. For those of you guys who haven't had physics yet, this will be a new idea for you. So first thing I want to do is I want to review, since we're doing everything in the context of particle problems, I want to make sure you guys are prepared with the old stuff first. It's kind of relevant. So when we're talking about particles, a lot of times we use S of t to represent position. Okay? And so whenever you take a position at time 2 and a position at time 1, S, if you take your position at one time and subtract it from another time, that'll tell you how much your position changed. In other words, what distance you traveled, right? And if you divide that by the total time that went by, t2 minus t1, then that basically gives you the slope. It gives you the rate of change, the average rate of change. And if you take the limit of this as t1 approaches t2, in other words, you're finding a point in time at which it's at one single point, you get the derivative. And so the derivative of s is the velocity function v of t. Okay? So velocity is the derivative of position. Now, you could do the same thing with velocity. You could find your velocity at time 2 and subtract it from your velocity at time 1. Subtract those two things, and you're going to, at that point, you're going to find the rate of change of your velocity, which is known as acceleration, right? But if you take the limit of this as you let t2 approach t1, you're finding an instantaneous velocity, in other words, a derivative of velocity, and that tells you acceleration, an instantaneous acceleration. Okay, so that's all old stuff that we haven't looked at in a little while, but there it is. So we use S to represent position, we use V to represent velocity, and we use A. Now that's what I do, and that's what most teachers do, and even probably I think even in physics. Hey, physics people, does your teacher use S for position at all? No? Okay. Okay. For horizontal. Yeah, you could do that too. But on the test, remember, you can't just throw variables in like that. So if they don't give you the letter V, don't use V unless you define it. So be aware of that. But in here, for the most part, that's what we're going to be doing. So now, acceleration, force in physics, force is mass times acceleration. Okay, and so I like to just think of acceleration as a force because it's the same thing as force, but just times mass. So it helps with understanding how force and speed interact. So let me go to this table here, and if you want to write this down, you can, but you don't need to. It's just review. Okay. So first of all, let's say that I have a positive velocity. Now, if I have a positive velocity, that means I'm going up or right, depending on whether we're on a horizontal or vertical axis. So if I have a positive velocity, that means I'm going up or to the right. Okay? Now, the size of that number that I have that's positive tells me how fast I'm going. So if my velocity is 5, that would be greater than if my velocity is 1. So I'm moving up or to the right at a speed of 1 unit per whatever, right? Now, if you have a positive acceleration, I like to think of that as a force. It's a force that's pulling you in the positive direction. So if you're moving in a certain speed to the right, and then a force starts to pull you in that direction as well, what happens to your speed? You're going to go faster. So you'll be speeding up. Now for negative velocity tells you how fast and in which direction, just like positive does, right? It's just that for negative velocity, the negative means you're either going down the y-axis or you're going left on the x-axis. Okay, so that's what negative velocity means. It means what direction you're traveling. Okay, and once again, the bigger that negative number, the more fast you're moving in that direction. So -5 is a faster speed in the negative direction than -1 would be. And if you have a negative acceleration, that means your acceleration is working with it again. If you're moving to the left and you're being pulled to the left, then you're going to go faster to the left, and so your object will be speeding up. But anytime the acceleration and velocity work in opposition to each other, you're going to slow down. So if your speed is trying to move up or right because it's a positive velocity, but your acceleration is pulling you this way and you're trying to go that way, that's going to slow you down, right? Same thing happens over here. When you have a negative velocity, you're trying to go down or left, but the acceleration is in a sense pulling you up or right, and so that's going to slow you down also. Okay, so that's position, velocity, acceleration, and speed, and how they're all related to each other. So velocity is the derivative of speed. Acceleration is the derivative of velocity, and then velocity and acceleration go together to help you know whether something is speeding up or slowing down. Okay? And in case you guys forgot, another thing is that speed, not speeding up or slowing down, just speed itself is the absolute value of velocity too. It's just how fast it's going. It's not with regard to the sign, whether it's going left, right, or down. It's just how fast. So that's all those concepts that we reviewed a while ago. So now that we've hit those up again, let's kind of refresh our brains on some things here. So I have a velocity graph over here. That's a graph of v of t. Okay? So moving along the y-axis. So if this is v, then what does v prime represent? It represents my acceleration. And on this graph, v prime represents the what? It's the slope. So the slope of these lines represents your area or your acceleration. Now, what does the integral of v represent? No. The speed would be the absolute value of v. Position. So position is the integral of velocity. Now how do you find the integral of this function here? By doing what? The area under the curve. So basically here's what we're doing. The area under the curve tells you stuff about the position. The slope of these lines tells you something about the acceleration. The graph itself tells you what the velocity is. Okay? So for instance, if I pick a point right here, I have a positive slope, so my acceleration has a slope of 1. So my acceleration is 1 at that point. Also, my velocity is 1 because that's the y value at that point. And if you wanted to integrate this, that's a triangle. So that would be 1 times 1 cut in half is a half. So somehow my position is changed by a half, basically, is what that means. So, yeah. Uh-huh. All right, so now that we've kind of got it going there, I want you guys to look at this, and I want you guys to find out what interval is the acceleration positive. So think about that for a second. Probably should use parentheses. From 0 to 3. The reason is because on that interval, v prime, which is equal to the acceleration, is greater than 0. We have a positive slope there. Okay. Next question that's going to come up is where is the acceleration negative? So ponder that for a second. I'll call on you to share out that answer. Where is the acceleration negative? What do you think, Nathan? Where's the acceleration negative? Good. So, well, it's not -5, just 5. So 5 to 9. And I'm going to use parentheses once again because at this point, there is no slope. So we can't say the slope is anything at that point. That's a cusp. And here, that's an endpoint. We could maybe say that one has a slope. Yeah?
Do you have to write it like in the parentheses like that, or could you put like 5 to 9?
Yeah, you could do that. You could say it like that. So that would be because v prime, which is the acceleration, is greater than, oh, sorry, less than, thank you. Less than 0. We have a negative slope at that point. And remember, guys, do you guys see v of t in this problem here? Mm-hmm. So you can use that on an FRQ. Do you see a of t up here? So you would not be allowed to do that on an FRQ without defining it. I'm just being lazy and quick here. You can't just make up a new variable without defining it, okay? You have to define it. Yeah?
So, like, how you at the beginning, you're like the integral of v of t is speed. Like, that's what you mean by the.
Yeah, I guess so. That would work, yeah. Mm-hmm. All right, so next one. Now, when is the object speeding up? Now, we talked about speed. Speed is whenever both acceleration and velocity are positive. Okay, now, we already know where the velocity is positive. We answered that in question 1. Can somebody with a raised hand tell me, how can you tell where velocity is positive? Jules?
Where's the y? If it's below that x-axis.
Okay, so if it's above the x-axis, velocity is positive. If your graph is above the x-axis, then the velocity is positive. If it's below, it's negative. So now the question is asking us, when is the object speeding up? So you need to find out when is the velocity and acceleration both positive, or when is it both negative, because both of those situations are whenever the graph is, or your function, your particle is speeding up. So ponder for a minute. I'm going to use my cards to call on you. What was your answers?
It would be for when it's speeding up.
Uh-huh.
It would be when the graph is above the x-axis.
No, not quite. Not quite. What do you think, Marcos? Yes and no, but go ahead, Marcos.
I got from the interval 0 to 3, and then from 6 to 9.
I guess no brackets once again, parentheses. 0 to 3 and 6 to 9. I agree. Okay, now let's see why. On 0 to 3, look at this interval. How do I know that my acceleration is positive? Because the slope is positive. How do I know the velocity is positive? Because it's above the x-axis. So since they're both positive, that's speeding up. So since v and a are greater than 0, it's speeding up on that interval. Over here, how do I know that the acceleration, what's the acceleration over here? Negative, because the slope is negative. How do I know the velocity is also negative? Because it's below the x-axis. And both of those are situations where the speed would be increasing.
Oh, because it's going, wait, what? Oh, so it's going faster, but in a negative direction.
You got it. Nice job. Okay, so there you go. Is the next question, when is it slowing down? Okay, so I'll let you ponder that for a second. Next question was, when is it slowing down? And that's from 5 to 6. Because on that interval, what's my acceleration? Negative, because I've got a negative slope. And what's my velocity? Positive. So since they're opposites, that slows things down. My object is trying to move up, because we're moving on a y-axis, it's a positive velocity, so I'm trying to move up, but the acceleration is pulling it down, so it's slowing it down as it's trying to go up. Okay, and so we would say that that is because v is greater than 0, but a is less than 0. Okay? When is the object moving up the y-axis? So direction is a velocity thing. So I'll give you that. That's true, but that's not the answer I'm looking for. Isn't that weird? Hi. No. It's 0 to 6. 0 to 6. Now let's see, why is it 0 to 6? Because if it's moving up, my velocity must be positive. And my velocity is positive when we're above the x-axis. So from 0 to 6, we're above the x-axis. And so the next question probably is asking, when is it moving down? So Manny, when would this object be moving down?
Alright, so it would be moving down from 6 to 9.
You got it. Since v is, in this case, less than 0. Okay, I think that's it for those guide practice questions. Am I right? So that was just some review. That's stuff that we've already done. We haven't looked at it in a little while, but hopefully that was helpful to you guys. Seeing the relationship between position, velocity, and acceleration, and speed, and how to determine those by looking at a graph. All right. So now let's move into some new stuff. Some of you guys don't know the difference between displacement and distance yet. Let's say that I start at 1. Okay? And let's say I decide to go for a little walk, and I walk all the way over here to 5. I'm not happy there, so I decide to walk back, and then I decide I'm going to go ahead and stop here at -4. So this is where I stop. I'll put F for final, and this is where I start. I'll put S for start. All right, so what distance did I travel? Say it again. 9? 14. Okay, I know what you did. Okay, so what we did was we did 1 to 5, which is 4, right? And then we went from 5 to -4, which is 9. And so the distance that we traveled, we got 9 plus 4 equals 13, right? Now, distance is a geometry concept. Bless you. So when we're talking about distance, we don't concern ourselves with negatives. But I did change direction, didn't I? So direction kind of matters for something. It would be one thing if I just walked 13 spaces all the way to the right, as opposed to 4 this way and then 9 this way, right? You end up in different spots. So displacement is whenever you do the same thing, but you actually concern yourself with the signs. Okay? So how far did I move at first? 4. I moved 4 at first, and was that in a positive direction or a negative? And then what did I do? I went 9, but to the left, so what am I going to write? And that gives me this. So that number there is what we call displacement. Now that's a little bit harder to understand what that is on this graph, but think about this word, and look at that number, and then look at your graph. Who can tell me what displacement is? What does that -5 represent, Brandon? Where's that at on my graph? Just to make sure I'm understanding you rightly. 1 to 5? No, it's not that. Yeah? Good. So I'm going to say it, Max just said, if you compare your starting point to your final point, displacement is how far apart they are. How far apart are those? It's 5, and where is the final point? It's to the left of it, so it's negative. So what displacement does is it tells you how far an object is and in what direction it is from its starting point. So when you include the signs, you get displacement. When you don't include the signs, you get distance. Now another way you could have written distance, by the way, is you could have written it the same way you did displacement, but just put absolute values on there, right? Distance is an absolute value concept. Matter of fact, that's the definition of absolute value. It's the distance from zero. So, knowing that, let's move into the calculus side of this. So, you guys remember how we talked about what does the integral of v represent again? Your position. So this is s of t. We're going to plug in the b, and we're going to plug in the a. So this is my starting position, right? And this is my final position. So the integral of the velocity from a to b gives us this, which basically just tells us how far apart our final point is from our starting point, right? And that's called displacement. Starting point, ending point. How far apart are they and in what direction? If it's negative, it's to the left. If it's positive, it's to the right. Okay? So, or if you're doing on a y-axis, that would be positive means above, negative means below. But if we take this idea, bless you, if we take this idea and we take the absolute value of that, well, not right here, not on the if we take the absolute value of that velocity, in other words, we ignore the direction that we're traveling in, and we just add together all the velocities over time, you get distance. Okay? So that's the difference between distance and displacement. If you integrate your velocity over an interval, that's going to tell you how far apart your ending point is from your starting point. If you integrate the distance, it doesn't tell you where you land, but it will tell you how far you traveled. Okay? So, that's distance and displacement. This should look a little familiar to you guys, no? Okay. This is what we've been working on for the past few days. But it's with a different, we're talking about it in a different context now. What does this represent? Final position. Good. What does this represent? Now, we called this the net change in the past few days, right? But today, what are we calling it? Displacement. If it had absolute value, it'd be distance. So check this out. Let's connect this to our number line problem. Remember my number line problem? I started at what? 1. And then I went to 5. And then I went back to -4, right? And what was my displacement? It was -5. So, what was my final position? What was my starting position? What was my displacement? So if you take your starting position and you add the displacement to it, it will tell you where the object lands. So it's the same formulas as we've been working with for the past 2 lessons. It's just that we're talking about it in terms of velocity and distance and displacement now. Okay? So final position plus starting position equals, final position equals starting position plus your displacement, which is really just your net change in a different context. All right, so that being said, let's jump into some problems here. So the velocity graph v of t is given at the right. We have a particle moving along the y-axis, so we're looking at a dot moving up and down the y-axis. S of 0 equals 4. So what does that represent? Someone want to tell me what S of 0 equals 4 represents? Yeah?
At time 0, the position is 4.
Good. At t equals 0, the position is 4. So we're on a y-axis here, right? It says. My dot starts right there at time equals 0. Okay? You don't need to draw that, but I'm just telling you. Oh, it actually even tells you what it says right underneath it. All right, find the displacement. So we talked about how to find displacement. Displacement is the integral of your velocity from your starting point to your ending point. So what's my starting time? 0. What's my ending time? 9. And so how do I find this? It's an area under the curve, right? So let's do that. So this would be 3 times 3 is 9 halves. This is 6. This is 3 times 1 1/2. And this is 3 times 9 cut in half, and it's negative. Right? So there's my areas. So it's 9 halves plus 6 plus 3 halves minus 27 over 2. And I'll try to do a little bit of mental math here, and you guys can check me. Let's see. That's 12. Take away 27 is negative 15 plus 12. I want to say negative 3 halves. All right, so there's your displacement. All right, so now we get to go to the fun question. Talk to Christian. What does that tell me then? I know that's my displacement, but what does that mean? Okay. Someone want to take a crack at it? Marcus?
From the original starting point, you moved negative 3 halves.
That's right. So from 4, was it 4? We're going to go down negative 3 halves, which is 1 1/2. So my final position would be right about there to 2 1/2 on the y-axis is what that means. Okay. Now that doesn't mean I just went from here to here, though. We might have went all over the place, but that's where we landed. That's our displacement. All right, next question. Find S of 9. I think I'll skip that one. Let's do distance. We'll come back to it. We'll come back to it. All right, let's do distance. So, how do I find distance, Samantha? Good job. Same thing as last time, but now it's just absolute value. And what that means is we're going to have the same thing. It's going to be 9 over 2. 9 over 2 plus 6 plus 3 over 2, and then what? Plus 27 over 2. That, might want to star that. That last area now becomes positive. And here's why. When we're asking about distance, if I'm doing this, that means my velocity has value, right? It's not 0. I have a velocity, which means my object is moving on this interval. And if it's moving, we're covering distance. On this interval, we're moving to the upward direction. Here we start to go back down. But so at the beginning we start at 4, we're moving up, and then as soon as we get to 6, it starts to come back down again. Okay? And so we're still covering distance even though it's negative. So to find the distance, we just take the absolute value of that area under the curve. And what that ends up giving us is, how much? 25.5? Okay. So there's that. So I'm going to clear that. Let you guys try one like that real quick before we move on. Go ahead. I want you guys on your student practice here, I want you guys to do 1 and 3. And I want you guys also to notice that you're moving on the x-axis and you have a different starting point as well. Okay? So for displacement we had, what was it again? Negative 13 over 2. And for distance we had 35 over 2. All right, let's go back now to this previous example here. And we're going to do some other stuff now. So back to number 2. Find S of 9. Find S of 9. Well, anytime you want to find a position, here's how we're going to do it. We're going to use this guy. my final position is equal to my starting position plus the displacement. Okay? So, if I want to find S of 9, that's going to be equal to my starting position, plus my displacement from 0 to 9. Displacement, not distance. Okay? So, S of 9 then is equal to, what's my starting position? 4. Says it right there at the top. And we've already calculated our displacement. What was my displacement on number 1? Negative 3/2. So that means that when t equals 9, my position will be at 5/2. I'll rewrite that. Didn't turn out well. Did it again. So in other words, at t equals 9, my position is at 2.5, which is 5/2. Okay? So that's how you can find the position of an object, is just using our formula there for integral functions. Now the next few questions, which I'll bring back for a second, but I'm going to get rid of them again because I need some workspaces. They're all going to be able to be answered by doing the same thing. So I'm going to do that thing first, and then we're going to answer all 3. All of them have to do with finding the greatest something. Okay? So number 4, which one is furthest from the starting point? Number 5, which one is the highest point on the y-axis? Number 6, which one is the lowest point on the y-axis? That should say y-axis, by the way. Well, anytime you're looking for a highest or lowest, they're asking for a max or min. And how do you find maxes and mins? Candidates test. Candidates test. All right? So, we're going to do the candidates test, and by doing that candidates test, we're going to actually end up answering all 3 of those questions at once. So, here's the candidates test. It starts off by putting your input variable here, and which one you're trying to find the min or max of. I'm trying to find the maximum position, right? I want to know when is it farthest away from the origin, or furthest up, or furthest down. So I want to find the maximum of S of t. Okay? Now, when it comes to finding your candidates, we know that your candidates are what? Your beginning point and your ending point, but also critical values. Now, critical values, in case you guys forgot, are where the derivative is equal to 0 or undefined, right? So now, don't you guys agree this is my S function here? My final position is my starting position plus the displacement from 0 to whatever I want to stop at, right? So if I want to find S prime, the 4 goes away, and what's the derivative of an integral? So my derivative of S prime is what we know it to be already, the velocity, right? And that's my graph. So critical values are where the derivative is undefined, or 0. So looking at if S prime is V of t, that's a graph of V of t, right? Where is V of t equal to 0? At 6. So there's one of my critical values. Does it equal 0 anywhere else? So technically 0 is a critical value also, but we already have that, so we don't need to include that one. Oh, where is it undefined? So where's the derivative undefined? Do you guys see any holes, gaps, or jumps in this line for the derivative? No. So we're good. Now, well, I should have said for velocity, not the derivative. But there you go. So there's my 3 candidates. So easy answer now. Ready? Your candidates are going to be the start point, end point, and where it touches the x-axis. Where it touches the x-axis, okay? That way you don't have to go through all this stuff in the future, but I want you to know where it came from. So I thought I would do it first. All right. So we've already done a lot of the work for this problem. We already know this one. What is S of 0? It's 4. Remember? Right there. We actually already did S of 9. We just did it a second ago. What was that? 5/2, which is 2.5, right? The only thing we need to do now is s of 6. So we got to go back to our s function and plug in 6. So here we go. S of 6 is equal to s of 0 plus the integral from what to what? 0 to 6. Okay, so this one here we already know is 4. Plus, I need to find the area under the curve from 0 to 6. So that's this. So 9/2, 6, and 3/2. 12. So s of 6 is 16. And now we're ready to answer all 4 of those questions. I'm not going to bring them up because they're on your guys' papers. But what was question number 4? Farthest from the starting point. Okay, my starting point was at 4, right? My starting point was at 4. Which of these positions is farthest away from 4? 16. The question is asking when does that happen? So when does that happen? At t equals 6. So at t equals 6, we are farthest away from our starting point. Number 5, what does that one ask us for? Which one of these positions is the highest point on the y-axis? It's at t equals 6 again. And number 6, which of these, when is it lowest? So which one of those is the answer? At t equals 9, because at that point it's 2.5. Now this makes sense, guys, because if I'm starting at 4, as I move up here, my velocity is positive, so I'm going up the x-axis, and by the time you get here, you just reach your maximum point, because after that, where does it start to go now? The dot starts moving downwards. And by the time you get here, if this area is greater than this area, you're going to end up at a point that's lower than where you started. Okay? All right, so that's that. That's the candidates test and finding positions. And I'm going to let you guys practice that now, and then we'll call it a day after that. So I would like you guys to do number 10, and then 4 through 6. Sorry, we're going to do 2 and 4 through 6. All right, so here's our answers for numbers 2 and 4, 5, and 6. So for 2, here's how you would calculate the position, and you should have ended up with negative 14.5. For numbers 4, 5, and 6, you do the candidates test. My candidates are 0 and 10 for the starting and end point. My critical values are 1 and 7, where it touches the x-axis, and we already have the value for 0 was negative 8. We already have the value for 10 was 14.5 from up here. We just have to figure out these two now, and those I've shown my work for over here. So for number 4 is asking when is the object farthest away from where it started? In other words, which of these numbers in this row are farthest away from my starting point, which is negative 8? And the answer is 19. So that means at t equals 7, it's farthest away from its original point. That's also the answer to number 6, which is when is the object lowest on the, or farthest to the left on the x-axis. So that would be the biggest negative number there, which is 19. So number 6 is also t equals 7. And then finally, the number 5 question was when is it farthest to the right? Negative 7 is the smallest negative number up here. So if you plotted all these on a horizontal x-axis, this one would be the one that's farthest to the right. So at t equals 1, we have the point that is farthest to the right.